Right, okay, so this first question, very important that you've read the question. It says, use as many bits as required. Okay? So, to stop yourself going wrong, put some column ends in. It doesn't matter if you put more column headings in than you need. So I'm just going to keep going. I can see I've got a really big number here, 278, so I'm going to go more than 8 bits. I'm going to 256. Looks like I'll be alright with that one. Right, so the first one, 13 in binary. So it's going to be zeros for all these, but when I get to 8, I can take 8 away. So I get myself a 1. I'll leave myself, I'm going to make myself look like an idiot on camera here, because I'm going to go, oh, I can't subtract. But hey, not the first time I look an idiot on camera. Why I can't just stick to what I'm doing when I'm doing these videos, I do not know. I don't know. This is why I've probably got a big fan base from Southeast Asia. Not that they'll understand anything I'm saying anyway. Right, so I've taken that off. That leaves me with 5. I can get 4 out of that. No 2s and a 1. So my answer only requires 4 bits. Okay. Now we could have known that because 4 bits is 0 to 15. So we could say, right, oh, I don't need any more than that. Okay. So the next one is 33. Now I've got my number line, my column ends here, so I can see that with 5 bits I can actually, and the easy way of doing this is it's 1 less than that one, I can only go up to 31, so I'm actually going to need 6 bits to do 33. That's another way of looking at it. Look at it how you will. Remember, with no calculator in the exam, which is the biggest problem. Right, so we can have a 32, and then that just leaves us with 1. So it was a 6-bit number, 33. Okay. Right, the next one, 278. Looking at this, 8 bits isn't going to cut it because the next column is 256. That is smaller than that. So I need, if I was to go one more, 512, I don't need 512. Okay, remember we just double up. But I do need 9 bits for this one. So I can have a 256, which leaves me with a 2. Oh, luckily it's 22, so I'm not going to look too stupid. So I can't have any 1 to 8s, can't have any 64s, 32s, but I can have a 16, which should leave me with 6. So I can't have an 8, but I can have 4 and 2. So you should have got 1 0 0 0 1 0 1 1 0. Yep. Okay, moving on. Where's my board? Okay, so remember this is all about data representation. What's my mouse? So we've got a pattern of bits. Remember, it means nothing until we say what it represents. So in this case, we're saying, okay, it represents first time an unsigned number, then a sign of magnitude, and then 2's complement. So we need to put some column headings on. So I'm going to put them up on top of there. 4, 8, 16, 32, 64, 128. So if it's unsigned, I just read the number raw. So we've got 128. Right, and I'm going to do my Tetris number. So 128 and 2 is 130. So that's 146, 147, I think. Anyone agree? Yeah. Okay, so I always try and make it easy to add up. I'm no good at adding up. If I try to add 16 to 128, I get it horribly wrong. So whatever system works for you. Right, okay, the next two are signed formats. So sign of magnitude. So what we remember about that is that the most significant bit is a sign bit, and that's where we start. So I'll look at that and I go, oh, it's negative. So the sign of magnitude minus, and then that's the easy one, just read it off. So it's 16 plus 2 is 18, plus 1 is 19, so it's minus 19. It isn't 19, it's minus 19. Okay, the 2's complement. Again, we can see it's negative, and because it's negative, we can't read it already, so we're going to flip and add. Okay, and I'll do the long-winded way, so I'm going to say flip, flip, flip. Flip, 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 flip. So I get that, so that was my flip. And then I'm going to add one, so I just look for the first row that direction, make it a 1. I haven't actually gone past anything, there's nothing else to do. So this gives me the positive version of that number. Okay, so I can now read that off. So it's 64 and 32 is 96, plus 8 is 104, plus another 4 is 104, so that's 105. So it's minus 105. Anyone agree? Nobody agree. Anyone agree? You got 109. Have I had it all wrong? Double check.
Use calculator.
You could use a calculator to check how useless I've had it all. I don't know, have I had it all wrong?
64 plus 32.
I flipped it right, haven't I? 64 and 32 is 96. Plus 4 is 100. 108, 109. Oh, 100, I've written it down wrong. Said it wrong in my head. Well, it is 109. Okay? Always double check. Okay? If you've got time at the end of the exam, very important with easy stuff like this to double check. Okay? Because I made a stupid answer, thrown marks away, but actually just checking it again, it's like, oh yeah, I did it all wrong. Okay? Right, let me scroll that back up. Right, hex and binary. Very, very, very nice. They're designed to work together. So converting between hexadecimal and binary is easy. Okay? So, we just take each digit, which represents 4 bits, and nibble. Okay? So we write down what 4 is in binary. I'll write these down over here. So we get 4 in binary is that. So that's the upper nibble. The 5 represents the lower. So we write down 5 in binary. So that's that. Okay? We'll do the ASCII conversion in a sec. So that's the first one. The next one is 61. So we just write down 6. 6 is a nice number. Okay? And 1. Next one, 73. So we get all the ones there. And 3, which is that. Then we get 79. So 9 is 1, 0, 0, 1. Okay, so you get a mark for getting each one of those correct. Then we need to know what the ASCII is. Now, when we look at these, okay, that's 64. And then we can look at these numbers. So that's a 4 and that's a 1. What did we say were the numbers that we need to remember for ASCII?
48, 65, 97.
Yeah. 48 was the digit 0. 65 was what, Max? Capital A. And 97 was? But we didn't need to remember that because there was something else, wasn't there? But the difference between upper and lower case is 32. So the lowercase letters are bigger, weirdly, but that's just how it is. Right, okay, so what does that make this character? Capital E, yeah? We can see it's uppercase because there's no 32 bit set. That one. That one is 0. So it must be, and I can look at it and say, hey, it must be an uppercase character. So that is E. The other way of looking at it, that's even easier, it's the 5th letter of the alphabet. Okay, so in binary they actually look quite nice. Right, the next one. It's got the 32-bit set. Okay, so this is a lowercase letter. The easy way of doing this again, so we know it's got the 64 set, so we know it's a character. They're not going to give you anything weird. And it says 1, so it must be A, first letter of the alphabet. So that is little A. This pen is rubbish. Let's try green. A little A. Okay, the next one. A little bit trickier. It's a lowercase letter again, but it is 16 plus 3, so the 19th letter of the alphabet. Which I think if I know what the answer is, so I'm going to cheat. S, little s, unless I've messed it up. Okay, so the 19th letter of the alphabet. And then this one, 16 plus 8 is 24. The 25th letter of the alphabet, I can do that one in my head. The 25th letter is Y. So you get a mark for each one. Capital E, A, S, Y. Easy. And they are easy to make a mistake. Okay. Right, okay, moving on. Okay, a task that the exam board would like to give you to test you, writing the same value down in different formats. Okay, so we're talking about signed numbers again. So we'll do the sign of magnitude ones first. Right, we want to write down 57 in sign of magnitude. If you're asked to write down a signed number, you start with what the value the sign bit should be, and you put that in straight off. So 57 is positive, so we're going to write a 0. Now it said 8-bit numbers, so just to help us, we're going to put some column headings on. And we want to write down 57, so we use the remaining 7 bits to write down 57. So I can't have 64, but I can have 32, which leaves me with 25. So I can have a 16. Oh, is it getting horrible? 25 minus 16 is 9. So that leaves us 8 and a 1. So in sign of magnitude, it looks like that. Okay, everyone happy with that? Yeah? Nice, get a load of confirmation there. Right, the next one, -1. It's negative, so we start with the sign bit again and we put a 1. Then we write down what 1 is. Well, that's an easy number to write down. Okay. Easy to make a mistake on that if you didn't put column heading, so you weren't counting how many bits. Okay, -32. Again, it's a negative number, so we're going to write down the 1 for the sign bit, and then we're going to put 32 down, which is easy. I made them nice and easy, so these are quick, these ones. And then D, -128. Your answer should have been not possible in 8 bits. Stick it. I'm not even going to attempt it. Why?
Because you can only go up to -127.
Yeah. If you think about it, the reason that is not possible with 8 bits is possible with 9 bits, but with 8 bits, you've gone, right, minus, because it's negative, the remaining 7 bits, you can only get 127 if you add all of them up. So you can't actually represent -128 in 8 bits. Do not be afraid to write down that something isn't possible if they ask you to do something. Don't do that for every question. Okay, because the likelihood is not every question on the paper is going to be impossible to do, unless someone's had a real meltdown at the exam board. Okay, so that one's not possible. Okay, so the 2's complement ones, you look at your number first. If it's positive, just write a normal number down. So just write your sign bit of 0 and write it down. So you should have got that again. So the sign of magnitude and 2's complement for positive numbers look the same. Always. Right, the next one. -1. Now we'll assume you don't remember that -1 is just all the ones. So what we do, if we want to write down a negative number, we say, right, okay, I can't do that. What I'll do is I'll write down the positive version, and then I'll perform 2's complement, and that'll give me the negative, which is the final answer. So I'm going to write down what 1 is. So I'm going to put a sign bit of 0 and write down 1. So I'm going to just indicate to the examiner that I know that is +1, that isn't my answer, I'm working it out. And then I'm going to flip. And then I'm going to add 1. So when I add 1, I get that. Okay, so that is what -1 looks like in 2's complement. Remember, that's the easy one. Don't matter how many bits it is, just write a 1 down all the way along. That'll always give you -1. Same with -32. We can't write it directly, so let's write down 32. So positive. Don't make the mistake of putting a 1 because it was negative. You're writing down a positive number. And we're going to flip all the bits. So we say flip, flip. Now what we can do is a quick way of doing this flip. We can say, right, okay, the last one, write everything down normal. Okay, so that gives us minus 23. My brain going backwards on me there. Minus 32. Okay, let me just prove it by doing the flip and add normal. So I can say flip, 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 flip. Look for the first 0, make it a 1. Everything you went past, you make a 0. So that's the answer. Okay, whichever method works best for you. The full long way of doing it shows the flip and add fully. Okay, but the quick way of saying, right, when you get to the last one, so let me do that quick way again. You go flip, flip, add. That's the last one. Write it down as a 1. Leave the rest unchanged. It will just be a load of zeros. Okay, and then minus 128. You can't write minus 128 unless you know it. Minus 128 is that. It is the equivalent of minus 0 in sign of magnitude. We use it to say, okay, 2's complement, we get an extra negative value. Okay, so if you're ever asked to write what the maximum 2's complement value is in a certain number of bits, just put 1 and then fill it with zeros. And that will always be the maximum. So if you did it with 4 bits, that would be the maximum negative number, minus 8. Okay. If you perform flip and add on that 2's complement, you get the same thing. Okay. Right. Okay. Moving on. Fixed point. Binary. So it can represent fractions now. So let's just scroll this one up a little bit. Okay. So this is exactly the same as doing integers. We're just saying like, well, that's where the 1 column is, but we're going to have some more that are less than 1. So we just go 1, 2, 4, 8. But as we go this way, so the binary point's going to go there. Don't ever call it a decimal point because it's not, it's a binary point. And then we just get half smaller. So we have half, quarter, 8, 16. Okay, that's all you do. Whenever you move right, you divide by 2 each time. So all we're doing is we're extending that. And we're saying, okay, that's what we can do. So we want to write down 2.25. So that's a positive number. No, 1. That's the 2 bit. You get a mark if you got that bit right. Okay, so if you got the integer part right, you get yourself a mark. And then we want to write down 0.25, which as mathematicians, we know is the same as a quarter. Okay, so we go, okay, there you go. So you get another mark if you got the fraction part right. Now, we then get a number that's in this format and we need to read it back. So let's just use those column headings and write down that number that's in the paper. So 0, 1, 1, 1 and 1, 0, 0, 1. So you get 2 marks again. So for getting the integer part as 7, you get a mark. Right, the fraction part. So I'm going to write it as a fraction because I haven't got a calculator in the exam. So I've got 1/16, but I need to write this in terms of 16ths, so that's 8. So I've actually got 9/16. Okay? Don't. What? Oh, is a decimal? Oh, is that what you've done it as? Well, if we know 0.5 is half, but a 16th is 0.0. What is it? 1, 2, 5, 6, 5, something like that. 625. Yeah, I knew something like that. This is why I don't bother. It's not necessary to do it. You'll get the marks for doing it in 16th. So it would have been 5/625. But you haven't got a calculator, so they're not going to expect you to start doing 1 divided by 16 because you'd have to do it long division. Who's going to do that in an exam? Not me. I'm not going to do that. Horrible. Okay. I'm surprised that's not on the syllabus actually. When I did A-level computing, we used to have to do multiplication and division of binary, and they're not pleasant at all under any circumstances. Okay, so you got a mark for the 7 and for the 9/16. Right, okay, the 3 test your questions. Not equal to in pseudocode, according to the what you need to learn, is that.
Doesn't matter which way you put it around.
Yeah, yeah. If you put that. What? Question mark. What you did? Yeah. You did that, but with a question mark. Oh, Lauren. Won't do it again. Right. The nice thing about that is in most languages the thing that's used when we're programming. So you'll see this a lot. Alright, so it isn't something you've got to try and remember. Okay. You are allowed to use that as well. So you do a less than and a greater than together. That's the actual one used in Visual Basic.
So it doesn't matter which way you put it around.
Oh yeah, definitely, because we also have things like this, which is equal. It's something the same as something else. So yeah, the order matters. If you do that in most C-based languages, what it would be expecting you to do is give it a value to, and this is the not operator, so to do a flip. So if it was true, it would make it false. So on its own, it means that. So it'd actually throw a wobbler at you. Okay, Boolean algebra, which we've got to learn later on, which is to do with logic circuits and things. There are 2 different symbols that you could have put. You can have this, which is actually the mathematical symbol for congruence, equivalence, exactly the same. Or you could have had this symbol. It's up to you which you want to use. We'll have to get used to both because you never know what the exam board are going to throw at us. So we need to make sure we remember those. Well, we'll get on to that. I'm not expecting you to remember that. And then, draw the diagram for a many-to-many relationship. Now, if I asked you to do this last year, you'd have created this diagram from that guide at the exam board. You'd have done this diagram. Which is absolutely nuts. Okay? It's wrong. That was the diagram that was in the book, in the What You Need to Learn last year. That's one of the things they've updated on it. The diagram you should have created. This is to do with databases. So, if your mind's switched off, I do completely sympathise. We do what we call a crow's foot. Because it looks like a crow's foot. It actually doesn't look like a crow's foot because they've got nasty, massive claws, crows. It's more like a robin's foot or a sparrow's foot, not a crow's foot. Crow's foot. If you did a crow's foot, I'd expect you to at least do massive dismembering claws at the end. Or golf clubs. They shouldn't call it a crow's foot. I think that's wrong. Right, and the last question, the bonus question. Not that anyone watching this video cares about this, but hey, it's the test themselves. The capital of Peru. Put your hand up if you said Lima. Well done. Odd. I don't know why I remember that. That was just one of the hideous things I had to remember in geography years and years ago. Right, I'll stop the video. Right, I'll upload that to